To create your own packets, you can do something as simple as browse out to a website or do some other networking activity and just capture packets in the background. And that's probably the easiest way to do it. But if you want to create custom packets so that you can watch what happens over in Wireshark, you can use a tool like hping3, which is very versatile, or you can use Scapy or something equivalent to that. So if we take a look at Scapy, to start it, just type in Scapy and Kali, but caveat, if you're not using Kali and you're a regular user, make sure you type in sudo first, because it does need access to the network stack, which you need to be an administrator for. So once we get it started, one of the things that would be very helpful is to be able to list out the kinds of packets that you can interact with. And to do that is ls. And since it's Python, you do need to have the function parameter parenthesis after the name of the function. And there are a bunch. So some of the ones you might recognize right off the bat would be the ICMPs, and then there's a TCP up here. And ICMP is in the stack, the regular IPv4 version of it, and you also have IP. And then, of course, there's all these other ones as well. Just lots and lots of different kinds of packets that you can mess with. So just to get started, so we can see the syntax, the IP and TCP are good ones to start with. So the basic way to create a packet is that you tell Scapy what kind of packet you want to use. For example, if we wanted to create an IP packet, we could choose a variable, maybe P for packet, and then set that equal to the IP packet that we saw in the list. And if you do p.show now, you should be able to see the different properties of the packet. So these properties are specific to this particular class of packet. IP has a version and a header length and type of service and so on and so on. And you can also change all of these properties as well to make the packet a little bit different. So if we start up another terminal, we can start TCP dump listening over in the other terminal to record the traffic that we create. So I'm not going to do name resolution because these packets that we're going to invent are not going to resolve well. I'm just listening to the local host, the LO interface. If you want to send packets over the network, you would need to change that to ETH0 or whatever the appropriate adapter is. And -v just gives us a little bit more information when it's running, and -w writes the packets out to the file that you specify. Now, if you're using Kali and you write to the temp directory, don't forget that when you log out and log back in, it generally deletes the user files that are in there. Depends on how you have it set, and you can change those settings with the tweak tool down here at the bottom. But if your packets go away when you reboot, that's what happened. Now you'll notice that there's a lot of traffic that's going on in the background between programs that are talking on localhost. So to get that filtered out, you can use the packet filters that are built into TCP dump. It's the Berkeley packet filters. So you can use any of those, and one of those that's included is the destination port. That's one way to filter things out. So if we say only capture things that are going to port 444, you'll notice that a lot of that background noise is not there anymore, since none of those background packets happen to be going to 444. So now it gives us the ability to change some information about the packets, but we're not quite ready to send any packets yet, because right now it's just an IP packet. It doesn't have a TCP packet attached to it yet. So earlier we did the IP packet, but if you use the /, you can stack the packets together. So from the point of view of the lower layer protocols, that's considered to be the left-hand side. So if you say IP and then TCP, you're putting a TCP packet on top of an IP packet. In other words, it's the normal orientation. But one of the things that's interesting about Scapy is that it doesn't actually care how you assemble the packets. And that makes it different than a lot of the other tools, because in a lot of tools, there would be no way to actually tell the program to take a TCP packet and put, say, an API packet in it. That's not normal, and they won't let you do that. But Scapy doesn't care. And if you get it backwards, it's not going to tell you. It'll just do exactly what you say. So if we say packet.show now, you can still see the API packet is there, but the payload of it is this TCP packet. Now there's a payload option. Oops. Okay, so if I'm talking about the variable P right now, remember that was an IP packet carrying a TCP packet. So from the point of view of this variable, the first layer is IP. If I say .payload, then what that does is it moves us up the stack one packet. So the payload of the IP packet is the TCP packet. So if I say p.payload.show, it's going to give me back the TCP packet. That way you can access the packets that are in your stack without having to rebuild the entire variable over again. And it also gives us the ability to change these properties here that are in the TCP packet without having to rebuild the IP packet. So if we say p.payload to get to the TCP packet and then say destination port or D port, we can set that equal to 444 and then do the show again to see the change. And you'll see the destination port has changed to this SNPP, which is the designated service for 444. So remember earlier the default was port 80, it was HTTP before, and then we changed it to 444. So now you can kind of see how to put the packets together, and it's actually fairly easy as long as you use the show command to show you what the choices are in that particular packet. It makes it a lot easier to know what to change. Now there are a couple of tricky fields. For example, the flags are a bit mask. So there's different ways to actually set that field. It's set to the SYN by default, and in the bitmask, so the flags from right to left, remember SYN is the second flag. It's in position, well, 1 or 2, depending on if you start counting from 0 or not. And then the ACK is 3 more spots over, generally considered to be in position 4 if you start counting from 0. So in order to set bits, you have to figure out what the pattern is and set the pattern, or you can use the integer that would be equivalent to what that binary would be like. So for example, if we said that the flags were going to be equal to 2, that would be the SYN. So if we set it equal to 2, it should still be the S. Because the SYN is the second flag in the bitmask, and in other words, it's the 2 to the first power position, the 1 position, so 2 to the 1 is the number 2. But remember the ACK is 3 more spots over, so in a bitmask that would be 4, 8, 16. So you got to take 16 to get the ACK, and then if you add 2 to keep the SYN, that would be a total of 18. So if you want to do a SYN ACK, then it's basically just set it to 18. And then that'll change it to SYN ACK. There are other ways to set this as well. You can check the Scapy documentation to see alternate ways to set the flags. But that's the only one of the very common parameters that you probably want to mess with that actually is a little bit different than just setting a string or an integer. Another slight tricky thing is that the source and destination IP addresses are strings, so when you set them, you need to set them with the quotes around them because they're not numerics, they're string fields. But they're already set to localhost by default. The .show is a pretty nice way of figuring out what the properties are, but you can also use that same ls command we talked about earlier, but instead of leaving it blank in the parameter, pass in the class that you want to look at. And the nice thing about doing the ls as opposed to the show is it doesn't just give you the name and the current value, but it tells you the name and the data type, and then it also gives you the default value that it'll set if you don't tell it anything else. So if we did that for TCP, we should see like that the port was 80, destination port's 80, the source port is 20, FTP data, and you can see that the flag by default is 2, and that's why it was SYN by default. For the most part, the only flags they usually need to mess with in the beginning is just 2 and 16 SYN and ACK. And of course later you'll want to mess with them just to see what they do. All right, so let's go ahead and create a packet and capture it. There's a few different ways to send packets. If you just want to send a packet, fire and forget, you can just use the send command. So if we send the packet P, it'll send it and it just forgets about it. Now over here in TCP dump, you can see that one packet arrived. If you want to send a packet and wait for a response, which means you'd have to be interacting with some kind of a service, like an FTP service or whatever, maybe a web server, you could send a packet to a web server and wait for a response. You can do send receive or send receive one. Send receive one is special because it sends the packet and waits for one single response, and then after it gets the response back, it'll stop. Now in this case, we're sending the packet to port 444, and there's nothing there, so we're not going to get a packet back. So we have to do a Control-C to get out of that wait. Otherwise, it'll just kind of wait forever. So the send, if you're just sending a single packet, is the best way just to send one single packet. And now that we got that, we can go over here and look at our packets. And you can type in Wireshark space in the path to temp packets to open it up, or you can open up Wireshark and use the file open command if you want to do that. But here is our packets. And we can see the one field we messed with a little bit was the port that we're sending the packets to, the destination port, and then we also changed the flag. Now Wireshark is displaying this in hex, so it says 12, but that's equivalent to the integer 18 that we used. And it says that it's SYN-ACK, which we already knew, and shows you the position of that. So that's an easy way to create your own packets to help learn about capturing packets, learn about what packets look like in Wireshark after they're generated. And again, the really nice thing is that you can create just any arbitrary packet. You don't have to create packets that conform to the standard network protocols.